Welcome to East Academia. My name is Brian, and today we are going to look at evaluating limits through rationalization. And usually this method is used in the case when you have a root or any other complex situation, in which case you're going to use a conjugate to rationalize any term that is not okay to be dealt with. Now, I'm going to take an example that we are told to evaluate the following limit, and you are told the question is limit as x approaches 9, okay, of 3 minus root x over 9 minus x. So this is the question, and this you're supposed to solve it. So we shall go to the solution. So we can, because we have a root, we can try to rationalize, and since the root is in the numerator, we can try to rationalize the numerator. And so we are going to have, it is 3 minus root x over 9 minus x. You multiply by the conjugate, which is 3 plus root x, 3 plus root x. In this case, you multiply by the conjugate in both the numerator and the denominator. Note that if you cancel this, you still maintain the original one. All right. So then you will have a function that looks like this. So the numerator, this is how it looks. But when you look well, this is it looks like this one. The numerator looks more of a minus b into a plus b. So of course this one, what do we expect to give us? We expect to get a squared minus b squared, the difference of two squares. And this is what we learned in the previous video. So in essence, this numerator is going to be 9 minus x, 9 minus, it's going to be x squared, 9 minus x, yeah? It's going to be, the numerator is going to be 9 minus x over, now this side, you are going, because this, okay, why it's 9 minus x is because this x is square rooted, so the square of a square root is, you just remove the square root, and then minus 9 minus x into 3 plus root x. Okay, so even before I proceed, we were supposed to test this on direct substitution first before we go to rationalization. So I will just come and show it here. So on direct substitution, we are going to have 3 minus root 9 is 3. So 0 over 9 minus 9, 0. So it's indeterminate. So of course, direct substitution cannot work in this case. So our only our only shot is to go with rationalization. But of course, the other methods, you can also use other methods. But let us solve with rationalization first. And then you realize this can cancel with this, isn't it? So we are going to have now limit as x approaches 9 of limit as x approaches 9 of now 1 over 3 plus root x, something of that kind. So we're going to have it's 1 plus 3 plus root 9. You're going to 1 plus 3 plus 3. You're going to have 1 over 6. Yeah? So the answer to that question is 1 over 6. Anyway, when you look at this question, if you are keen enough, you are able to see that you can solve using factorization, all right? Because when you look at this one here and this one here, the below one, it's like this one. You can see this one is 3 squared, this one is this one. This one squared, you get this one squared minus this one. So of course you can also use this principle here to solve this one, okay? So if you are supposed to, if you were to use, let me write it here, 3 minus root x over 9 minus x, and assuming I'm supposed to use factorization, I will take 3 minus root x, okay, and factorize this denominator because this is a squared minus b squared. Yeah, so it's supposed to give me a, this is a, isn't it, plus b, a minus b, isn't it? So in this case, my a is 3 and my b is root x. So 3 minus, this is 3 minus root x, and this can cancel, and I'm going to remain with 1 over 3 plus root x, and when I substitute the value of 9 here, I get still it's 1 over 6. So for this question, you could have solved it with either factorization or rationalization. But in essence, that's how rationalization works. And I think we can have an example of rationalization. Let me see which one is an appropriate example for us to use for rationalization. We can, for instance, no. I'm getting a good example here, but it's a thing that we can use. Anyway, it is as simple as it is. So for this one, I don't have another example of solving it through rationalization, but of course, that is how we usually solved or limits are evaluated through rationalization. So thank you for watching this video and have a nice time. Remember to subscribe to Academia and share widely.